Hi everyone. So we already said quite a lot about random walks with drift, trend stationary process, and we discussed some basics of unit root tests. Okay, today uh, I'm gonna show you how to do this, how to apply this knowledge to a real data. Okay, I'm gonna use R, but of course you can use any software you want. I know you've been working with eViews, so I'm gonna also show you how to do some of this stuff in eViews, because in another movie I'm going to explain what will be your task in your midterm. Okay, so uh, but let's start with what we are going to do here. Okay, first, I'm gonna load some packages, but this is not important. Look, and now I'm loading the data for I'm loading the data of real GDP for different European Union countries. But of course, we do not have the time to go through all of them. I've just chosen two, and let's see what results we will get. Okay, first, let's see uh, real GDP, quarterly real GDP of Germany from 1996 till 2019. Okay. And so here you see the graph, but I'm gonna use actually this one because it's much nicer. And what do we see over here? Look, we generally see that the GDP has been increasing, which is not a surprise. We clearly see also some downturns. The most important one being associated with the crisis of 2007 2008, but of course prolonged a little bit due to sovereign debt crisis in Europe. But look, we clearly see that we could fit here straight line, and the GDP rather fluctuates around it, with 2009 crisis, 2008 crisis being a really special case of very severe economic downturn. Okay, now let's look at like the graph for Poland. Okay, give me a second. So look, in here we see that this graph stands in glaring contrast with the other one. Why? Look, we see almost perfect straight line going upwards. Well, this would generally mean that Polish GDP was not struck severely by the economic crisis of 2008 and 8. Of course, we see the downturn here, but as you see, it's not a big one. We probably see more of a slowdown afterwards, but still, this line almost resembles uh, a straight line. This graph almost resembles a straight line. Now look, let's compare the two on one plot. Okay, of course. So look, when we put the two together, we see that they're definitely different. They both have some of the same properties. Well, they share the property that they are both increasing, but as you see, the volatility of Germany's GDP is way, way bigger. Okay, So maybe we can use this information somehow to compare the two GDP time series using what we've learned in advanced quantitative economics. Okay, so look, I'm gonna make a graph. I'm sorry. Now we need to do some calculations. So I'm extracting the data for Germany's GDP, and I'm also making first differences. As you remember, in the previous movie, what we had to do is to regress delta y on y minus t, and this is what we're gonna do. This is the first thing we're gonna do. Okay, so we also need to have. So these are the differences, first differences, and of course we need to have lagged value of GDP. But look, and in the second, so this is the first equation that I'm going to assess. It's going to be first difference of Germany GDP regressed on lagged GDP and a constant, so a drift. And remember, in the second equation, we are adding also a time trend. So, okay. So let me calculate this. Oh, well, not me, but you know what I'm talking about. And let's look at the results. Okay. So we start with a regression with no time trend. And what do we see here? Look, here we see that the value of the parameter is clearly different than, it is not statistically different than 0. All right? The p-value that we see over here is 0. Over 0.9. So in this circumstance, we would expect that actual, remember, if this is raw, and if raw is equal to 0, this implies this implies that the coefficient delta is equal to 1. So this gives us some evidence that Germany GDP behaves like a random walk with drift. But okay, now let's see what happens. Now let's see what happens when I add time trend. And look, when I add time trend, now things change a little bit. But look, coefficient beta is statistically significant, but only at 10% level. And the same can be the same can be said about the coefficient on lagged Germany GDP. So look, we get we have very inconsistent evidence from this, right? But let's say that we want to go in this direction and see the behavior of Germany GDP, assuming transstationary process. Okay, so look, we can, in order to accomplish that, we can transform rho back into delta. And remember, the delta is A from our difference equation. So I can use this A to construct complementary function. And look, this is what you see over here. We will consider only 100 periods. And look, ADG, standing for adjustment, will show us how Germany GDP adjusted to a shock through time. Let's assume that this shock is, oh my god, too many zeros. 3 zeros. And okay, give me a second. Sorry. This is 3 zeros. Another 3. So we have 10 million. But remember that the data was already in millions, so we have a 10 billion shock to GDP. Okay, so what happens? I'm creating the plot for this. So look, now what we see is the graph of the complementary function using that we've obtained, assuming that Germany GDP is a translationary process. So what happens? We see, look, this is the initial shock, and we see that the Germany economy goes back to equilibrium. But look, it takes it quite a long time to actually go back to equilibrium. Remember, those are quarters. So even after 10 years, well, of course, look, the shock that I've chosen is extremely severe, but we see that even after 10 years, economy has not reached equilibrium yet. But let's now. Oh, I'm sorry, not this. Okay, let's add some lines for references. And look, what do we see right now? Look, at this moment, so we see that half of the shock was absorbed in the economy in about, I want to say, 4 years, right? And we see that that economy goes back, like then here we have that 90% of the shock is absorbed after I want to say this is going to be, let's just say, around 7 years. And well, after 10 years, we can say that more or less the shock is absorbed. But look, this is a very lengthy process. Okay, so now let's look at the situation for Poland. So I'm going through all the same steps, and I'm estimating exactly the same two models now for Poland. Okay, and okay, let's start with the first one. Okay, and look, here we have a different scenario. In case of Poland, the OLS estimate suggests that the value of the coefficient is statistically different than 0, and even at 5% level. So not bad. So we actually have here some evidence that maybe trend that unit root here is not present, and that Polish economy should not be described using random walk with drift. And look, but now when we look at the second model, look, a very weird thing happens, because now we would expect that the outcomes for this model will be better, but actually they're even worse than in case of Germany. So looking at those two, we see that neither of these models works really well here. But look, again, as I told you, we are using here OLS. OLS is not the best estimator for this case, and we are using t-statistic, t-distribution. We should be using a Dickey-Fuller distribution that I'm going to show you in a second. But let's work what we have here now to just see the adjustment process. Now, again, let's go through the same steps. We can use the parameter we've obtained here for lagged Polish GDP to construct graph of complementary function with the same parameters except for adjustment coefficient, and we will see how Polish economy is adjusting to the same shock, to a shock of the same magnitude. Okay, let me already add the lines, and look, I know that in principle the graph doesn't look that much different, but maybe when we compare the two, you will be able to see that actually. Let me check one thing. If everything here is right, times 3, final 2. Okay. I see the mistake. I'm sorry. Okay, so that the graphs are actually looking too similar. Oh, and look what do we see over here? So look here, the complementary function goes back to equilibrium way slower, so it dies out slower. Look, in order to actually absorb half of the shock, we need, well, definitely more than 5 years, and even 90% of the shock is still present in the economy after more than 16 years, and even after 25 years, we still have we still see some impact of the shock. But look, where those differences come from? Look, those differences can be explained on economic grounds. Those two countries use different type of economic policy to combat the crisis, but they have different adjustment mechanisms inside the country. So the wage elasticity in Poland and Germany is completely different. Then again, there might be some econometric reasons for that. Look, first of all, you see that the graph of Polish GDP was very smooth. So actually, we didn't get to see much of an adjustment in the graph. This is why the procedure we used here might not work the best. But secondly, remember that we have not used proper distribution to assess the properties of the time series. Okay, so this is what we are going to do right now. Okay, I know that you've been using eViews in your econometrics class, so I'm gonna use eViews here as well. Okay, let me check. I think I have it here. Oh, it does not work for some reason. Give me a second, please. Okay, a little intermission due to technical issues. Okay, I think it should. Okay, it should work right now. Okay, so I open a views. Mm, okay, so create. Okay, let me open the file with the data. I have it on desktop. Okay. Okay. So now let's check the properties. So here we can check the properties of them. Okay, so first go to Germany, and I go to View, Unit Root Test, and we're gonna do the standard unit root test, and this is enough for us. And look, here we have augmented decay filler test. This is the most appropriate one in the context of what we are doing here. And we see that here you have test for unit root in level. Level is just simply the value of the variable. Then we have what should we include in the test? Intercept. Well, we do not include intercept if we would expect pure random walk, but of course GDP is increasing over time, so we need to have at least intercept. Okay, and then we go to and then we click OK, and we see the result of the test. And look, here the null hypothesis is Germany has a unit root. Look, you can think about it as a null hypothesis that rho is equal to 0 or delta is equal to 1, or from the context of difference equation that A is equal to exactly 1. And look, the p-value here is 0.9386. So in this context, we see that this test brings a strong arguments for the unit root and random walk with drift hypothesis. Okay, but now let's you try the second specification. So trend and intercept. So now we will have both intercept and the time trend, and what do we get? Look, actually, introduction of the time trend here did not alleviate the problem of unit root. We still have the unit root. So actually, we see that the model with no time trend is a preferable model for GDP. Here you see all the values from the model. You see, even though here time trend is statistically significant, we cannot reject the hypothesis that we have the unit root. Okay, now let's do the same thing for Poland. So we open Poland, unit root, and we start with, let's start with just intercept. Well, so here we see null hypothesis. Poland has a unit root 0.999. So here we have, look, contrary to the estimates we've obtained with OLS, here we have very, very strong evidence that Poland, a Polish GDP, has a unit root. Okay, so now let's see what happens if I'm gonna add time trend. Well, not much has changed. So again, very strong evidence for random walk with drift hypothesis. Okay, now look, this is actually all you need to know for my class, but you will have to write a thesis. You have econometrics class, so let me just add one piece of information. What do we do? What are the consequences of the unit root? Look, when we have unit root, we should not make a regression because we will have spurious regression problem. Look, basically, two variables with a trend will always be statistically significant, even though they might not be related to one another. This is why we cannot make simple regression on one variable based on the other. We go to tools associated with cointegration, so we check for common trends. But in general, if you want to estimate some regression model or vector autoregression model, we take a different approach. Look, instead of using levels, we can simply use first differences. So, and look, if I'm gonna make a test on first differences for Germany, no unit root. If I'm gonna do the same thing for Poland, again the same answer. Look, so when you cannot use variables in levels, you just use first differences. In case of GDP, it's best to use GDP growth rates because they are also gonna be stationary. Okay, so in the next video, I'm going to explain to you what I would like you to do instead of a regular written midterm. Okay, see you in the next movie.